Let's tie a bow on this lab, shall we? So we got um, units of newtons. So the question that I asked you was, what has units of newtons? Well, force has units of newtons. Well, in particular, what type of force are we talking about? The force of gravity. Oh, if only we would have measured that from the beginning. Oh, wait, we did. We measured the mass in kilograms. We took the mass times 9.8 to get the weight, which is the same thing as force of gravity, and we got this. And so in reality, I got the force of gravity of the ball to be 2.95 newtons. In the simulation, because I used a 5 kilogram object, 5 times 9.8 is 49 newtons. So now let's just say, well, how does that compare to my slope? Well, let's look at the simulation value first. I'm going to do this side by side view if I can. I know it's kind of hard to see the graph here, but the top one here is the simulation. So the slope is 40, if I round it, 49 newtons. Oh my goodness. So the slope is 49 newtons. Oh, the slope of the line represents the force of gravity acting on the object. So let's just write that. So therefore, if I'm going to write my equation like Eg, that's equal to the force of gravity times the height. That's what we just found a way to quantify gravitational energy. Now, a lot of times it's written not like that. It's written like this. Eg is equal to mass times g times h. The reason, and you're like, what does that mean? Well, g, so mass is mass in kilograms. G is what's known as the acceleration. I don't want capital G. I want lowercase g, is equal to the acceleration due to gravity. And it varies based on planet. So what you would weigh here is going to be different than what you would weigh on Mars or on the moon or in Jupiter or something like that. So the units of the acceleration due to gravity are meters per second squared. And so therefore, this is basically how you would find the gravitational energy. You take the mass of the object times the acceleration due to gravity. Here on Earth, it's 9.8 meters per second squared times the height, or just the weight of the object times the height. That's your gravitational energy there. Now, one quick note about this is let's look at the other graph. Let me move my little face here. Up here. So then the slope here is 1.961. That's what we got in reality from the lab that I did in my living room. But the slope but the theoretical value of that, or the force of gravity, was 2.95. There's got to be something causing error there. So the question is, what is it?